Welcome to Hot Wire Cafe, the only kitchen in the city of Joulestown where electricity isn't just power, it's flavor. Today, we're stepping behind the scenes, into a sizzling story of how heat is born in wires. Meet Chef Toasty, the master of the kitchen, who reveals how tiny electric chefs cook up Joule's law, the ultimate heat recipe. So grab your apron, sharpen your math spoons, and let's heat things up, one electron at a time. Let's travel back to the 1800s, to the town of Salford, England. There lived a curious young man named James Prescott Joule. While most boys played outside, Joule was busy heating water with electricity, just to see what happens. He wondered, if current flows through a wire, where does the energy go? Why do wires heat up? And after years of clever experiments, in 1841, Joule gave the world this powerful formula. H equals I squared times R times T. Heat produced equals current squared times resistance, times time. That's why we call it Joule's law. Imagine a glowing underground tunnel in the city of Jouleton, where tiny glowing workers called electrons run constantly, carrying energy from the power station to homes. This tunnel is a wire, and the roughness of its inner walls represents resistance. As more electrons rush through, they bump into the walls, and every bump releases a bit of heat. The more electrons, current, flowing, the rougher the tunnel, resistance, and the longer they run, time, the more heat gets generated. That's exactly what Joule's law explains. The heat produced in a conductor is directly proportional to the square of the current, the resistance, and the time of flow. The classroom in the kitchen, visualizing Joule's law derivation. Inside the cozy hot wire cafe, Chef Toasty gathers her team of trainee chefs, playful electrons, in a warm-lit classroom at the back of the kitchen. Standing by a glowing chalkboard, she begins, to understand how heat is born in wires, we must follow energy's journey. She sketches a battery, a wire, and a resistor, showing the chefs, current, running through the wire to power the stove coil. Power is energy flowing per second, she explains, writing P equals V times I on the board. Then, beside it, she draws a little clock. If our chefs cook for T seconds, the total heat is energy over time, H equals V times I times T. Sizzling coil animations appear behind her. Chef Toasty then recalls Ohm's law, V equals I times R, and substitutes it into the formula. The board glows with, H equals I squared times R times T. To make it memorable, she flips a chart showing, I equals chefs, R equals kitchen obstacles, T equals time on the stove, and says, more chefs, more struggle, more time, more heat. She draws a triangle with H at the top, I and R at the bottom. This is your heat triangle. The story flashes back to James Prescott Joule spinning paddles in water in his 1840s lab, discovering that mechanical work could be converted into heat. Energy never disappears, he says, it just changes form. As the camera zooms back to Chef Toasty, she ends, every time electrons hustle through resistance, they cook up the heat, and that's the true recipe behind Joule's law. And that's the story of Joule's law, where more current, more resistance, and more time means more heat. Just like a crowded kitchen with stubborn pots. The more hustle and effort, the hotter it gets. Chef Toasty's golden rule. H equals I squared times R times T. Where electrons turn work into warmth, and science becomes sizzling magic. From the kitchens of Joulestown to the wires in your home. Heat is not just energy, it's electrifying effort. Stay curious. Stay charged. And never forget, every law has a story, and every wire has a flame.